the details, why are we not surprised? Because it's conservation of energy, right? That I'm not getting more power out than I'm putting in, and I'm getting the same power out that I put in. Well, as long as it's frictionless and so on, right? It's sort of the ideal machine where the power you get out is equal to the power you put in. But you see, wrapped up in all this is all the right-hand rules and all the equations from 2 weeks ago and Faraday's law, and you see how it all blends together. Okay, someone had some questions, and as usual, I talk too much. So, did someone have questions on assignment 10?
Number 12.
This is related to assignment 11. Which I hope you'll finish 10 and get started on. Okay, so watch this. Let me put this up so I can use the board. So I'm going to take this and make it a little bit easier to see. So there's 2 wires. So in this case, into the board is going to be the x-axis. So we have y, z, and x. And I'm going to have x be into the board. Well, it's actually out of the board. And so the current's going along negative x. And so I put the 2 wires with current going into the board. And the wires are separated by a distance 2a. And then if we go along the z-axis, and we go up here, a distance 2a, that's where it starts. Problem starts at a distance 2a. What's the field there? So this has a field that's circular around this. And the way to get the direction is draw your radius from the wire to the point where we're calculating the field. And since the field is circular, it has to be perpendicular to the radius. So the direction of the field is that way because of right-hand rule number 2. And how do I get the exact direction? It has to be perpendicular to this line. Why? Because if you have a circle, the tangent of the circle at any point is always perpendicular to the radius. And then when I do this one, I can see that the field is going this way. So I draw another line here, and it's going to be perpendicular to that radius. And so if this is wire 1 and this is wire 2, then this would be B1 and B2. Are you good, Josh?
Mm-hmm.
And the 2 y components are going to cancel. And the x components are going to add. And so I could write down that B equals 2 times either one of the BX's. And the BX is going to be either one of the B's, because by symmetry they're the same. And so the BX is going to be B cosine theta, where I'm choosing this angle theta, or this angle theta. And so this is 90 degrees, right? Because this is the Y, this is the Z-axis, this is the Y-axis. And so if that's theta, this angle here is 90 minus theta, this angle. And yet the vector and the radius are also 90 degrees. So if this is 90 minus theta, and I'm now looking at this right angle, this has to be theta. So try and work that out on your own, but just know that the angle that we need to get the cosine of theta is also here. And so this theta is, cosine of theta is the adjacent over the hypotenuse. So this is 2a. Let's see what the hypotenuse is. The hypotenuse is the square root of a squared
plus 4a
plus
squared.
2a squared, or 4a squared, or 5a squared. A squared plus 4a squared, 5a squared. So let's find the b.
Could you not also take the a squared out of the square root?
You could, that's a good idea, I like that. And so the b total is 2 times either one of these b's, and that's going to be what? Mu naught I
2
over
pi
2 pi
a or r.
a, which is that distance. So square root of 5a times the cosine of theta, which is adjacent, over hypotenuse. Okay. Well, I'm going to cancel. You can do whatever you want, but I'll just show you what I would do. I'd cancel these two. And this would become 5. And there's still a 2 there. So it looks like I'm left with 2/5. Oh, and I got, this is a squared, and that's a, right? So one of the a's goes away.
Mm-hmm.
So I get 2/5 mu dot I over pi a. You can check that, but I don't think I made a mistake. There's more to this. Oh, maybe not. Oh, well.
How do we get the square root of 5? I missed that part.
So this distance is A, and this is 2A. And so there's the hypotenuse, is this squared plus this squared, square root, right? So A squared plus 2A squared, which is 4A squared, square root. And so A squared plus 4A squared is 5A squared. And Josh just suggested that you take the square root of this and the square root of that, and you end up with the square root of 5, just times A. You could leave it this way, but I like this suggestion. So that's where that comes from. All right, I'm here a good part of today. Also, let me just show you. Try your, I encourage you to try this. If you go to Moodle, there's this thing, I'm going to move it down. In Moodle, you'll see this questions and answers. So if you have a question, submit it here. I'll move this down to the current week. Submit it here, and then if I answer it, everyone in the class can see the answer. And if you ask a question and you go in there to ask another question and you can answer someone's question, answer your classmate's question. Save me some time. But anyway, let's try using this and see what this helps.